Welcome to Maths for You channel. The past question on vector algebra from Oxford and Cambridge past paper. The question, it is given that ABCD is a quadrilateral. The position vector of A is I plus j, and the position vector of B is 3i plus 5j. Find the length of AB. The position vector of C is pi plus pj, where p is the constant greater than 1. Given that the length of AB is equal to length BC, determine the position vector of C. The point M is the midpoint of AC, given that vector MD equal 2 times vector BM, and determine the position vector of D. State the name of the quadrilateral ABCD, giving a reason for your answer. Let's start with the first part. I've done a little sketch for ABCD, the quadrilateral, and with the IJ axis. The O is the origin, so the position vector of A is OA, position vector of B is 4B, position vector of C is OC, position vector of D is OD, and so on. So first part, they ask us to find the length of AB. So prior to that, I would like to find the vector AB. Vector AB, and then the modulus of vector AB is length of AB. Vector AB equal vector position vector of B minus position vector of A. So the second letter AB, second letter, the position vector of second letter minus position vector of first letter. That's how normally do it. Unless otherwise you want to just look at vector triangle OAB. From that triangle, OB minus OA is AB. OB is given 3i plus 5i, minus OA is given I plus j. So simplified, 2i plus 4j. That is vector AB, 2i plus 4j. What we need to find the modulus of AB. So AB is the modulus of AB. The modulus of AB is the square root of the coefficient of I squared plus coefficient of j squared, which is 2 squared plus 4 squared. 4 plus 16, that is, if you simplify it further, 2 root 5. So AB is 2 root 5. That's first question. And second one, the position vector C is P is given in the form of P, and AB and BC are equal, and find OC. Right, okay. Right, so BC, I just take vector BC. BC is OC minus OB. As I said, the second letter, position vector of second letter minus position vector of first letter. OC is given in P, so PI plus PJ minus OB already given 3I plus 5J. So that is give us BC equal P minus 3I plus P minus 5I simplified. So equal the modulus of BC, give us BC. So BC, that is BC. BC equal modulus of vector BC. So that is square root of the coefficient of I squared plus coefficient of B j squared. That is P minus 3 squared plus P minus 5 squared. That is BC. But we've been given BC equal AB. So, equate that. BC is square root of P minus 3 squared plus P minus 5 squared equal. And AB we already found 2 root 5. Then square both sides. P minus 3 squared plus P minus 5 squared equal 20. Then simplified. So P squared, simplified, just P minus 3, expanded, plus P squared minus 6P plus 9. P minus 5 expanded as p squared minus 10p plus 25, that is equal to 20. Then there's a p, 2p's there, so 2p squared minus 6p and minus 10p, so 16 minus 10 is 16p, plus 9, 25, 34, and then if you bring 20 this side, that's minus 20, 34 minus 20 is 14. So that is what we have here. Then I took 2 as a common and then ignored that 2. P squared minus 8p minus plus 7. So if you could factorize this quadratic equation in P, simply put a little cos and p squared, 7 is plus 7, it's minus 7 times minus 1 is give us minus 8 plus 7. So and then again if you cross multiply it, so p minus p times minus 1 is minus p, and p times minus 7 is minus 7p, add them together, minus 8p, so it satisfies that. So the factors are p minus 1 and p minus 7. P equal 1, that is invalid because p is greater than 1 is given in the question. So only answer we have p equal 7. So p equals 7. Right. BC, we found that BC there. BC is simply just wanted to sort of stick to the pattern. BC equal OC minus OB. OC, that's what we have to find. OC equal BC plus OB. So bring that OB to one side. BC, P minus 3i plus P minus 5j plus OB is 3i plus 5j. P we have found now, P is 7, so 7 minus 3i plus 7 minus 5j plus 3i plus 5. Simplified. 4i plus 2j plus 3i plus 5j. Then if you simplify further, that is 7i plus 7j, that is OC. The position vector of C is 7i plus 7j. That is position vector of C. Right, now vector triangle. Now let's look at the question. So we found the position vector of C, right? The part C, the point M is the midpoint of AC, and this condition is given, and find the position vector of D. Okay. All right. Let's look at vector triangle ABC. So from that vector triangle ABC, AC equal AB plus BC. So if you look at the vector triangle ABC, so that is AC, AB plus BC equal AC. That is what, yeah, AC, AB plus BC. So AB, we already found in that first part, the 2i plus 4j. And BC, and 4i plus 2j BC we found here. BC is, yeah, it is here. 4i, that is BC. 4i plus 2j. 4i plus 2j. From that, if you simplify it, AC equal 6i plus 6j. AM, so M is the midpoint of AC, so AM is half of that AC. It's half of vector AC, the same direction, so that is half means 3i plus 3j, that is AM. Now look at vector triangle ABM. ABM, vector triangle ABM. From that, AM equal AB plus BM. So if I could bring that BM to one side, the BM equal AM minus AB. AM is, we've just found 3i plus 3j. So 3i plus 3j minus AB, 2i minus plus 4j from the first part. So if that, if you simplify it, 3i minus 2i is I, 3i minus 4i is minus j. So BM is I minus j. Then we have given a condition MD vector MD equal to 2 times vector BM. So MD vector MD equal 2 times BM. BM is found I minus j. So that is 2i minus 2j. So MD is 2i minus 2j. Let's, we need to find OD. Well, how you can find, we need to construct or sort of sketch, easier for to understand, a sketch OAMD quadrangle. So OAMD, if we could do this vector quadrangle OAMD, OD we need to find OD equal OA plus AM plus MD. OA is given from the first part is I plus J, plus AM, we found it here, AM is here, so AM is 3i plus 3j, and MD, again, we found it MD, that is 2i minus 2j. So simplified I, 3i, and 2i. So 4, 2, 6i, and 3i, j, and another 3j, 4j, minus 2j is 2j. So that is OD. So the position vector, this is the position vector of D. That's found. So that's part done. Next one. State the name of the quadrilateral ABCD, giving a reason for your answer. Right. So you need to see what that can be, that quadrilateral. Okay, I just draw that again, ABCD. AB equal BC, which we have been given in that first part, AB equal BC. So AB equal BC. Here, I'll look at AD. I just wanted to see AD. So AD is simply that OD minus OA, that second letter, the first letter format. OD, we know, we found it, that 6 plus 2j, 6i plus 2j. And OC, again, we found that as 7i plus 7j. So 6 minus 7 is minus I, 2 minus 7 is minus 5j. That is AD, OD, right, first with this one, it just OD is that 5, sort of 6 plus 2j minus I plus j. That is 6 minus 1 is 5, and 2 minus 1. Yeah, that is OD. And CD is this, as I just explained it. AD, where is the AD? Right, okay. AD is modulus of AD, give us AD, that is 5 squared and 1 squared. 5 squared and 1 squared AD, where is AD? Yeah, 5, 1, 5 squared and 1 squared, that is root 26. And CD, modulus of CD, again is minus 1 squared and minus 5 squared, that is 26. So that means AD equal CD. AD equal CD. So AD equal CD. AD equals, so those adjacent sides, two adjacent sides are equal. So AD equal, AD equals CD, right. AC, Let's look at AC, and I just need to prove a bit more. Sort of, we know that the adjacent sides are equal, but let's see whether we can develop more. Right, AC, vector AC is OC minus OA, a simple format. OC is 7i, 7j minus ij, that is 6i plus 6j, that is AC. BD is OD minus OB, that is 6i, 6i 2j minus 3i plus 5j. That is, if you look at that OD, the position vector of OD, and then position vector of B. So position vector of D and B. That is give us 6 minus 3 is 3, plus 2 minus 3, that is minus 3. So 3i minus 3, that is BD. If we take AC and BD, purposely I'm doing it, just to see what the relations between AC and BD. So AC vector dot product BD vector. That is modulus of AC, modulus of BD, and the angle between the two lines. That is the angle between AC and AD. AC and AD. So the AC is 6i plus 6j, dotted with 3i minus 3j, that is equal modulus AC, modulus BD, and cos theta. If we do that, the dot product 6 times 3 I, because ij is 90, 0, so I and jj. 6 times 3 is 18. Another 6 times 3, that's minus 6 times minus 3 is minus 18. So 18 minus 18 is 0. So cos theta, regardless of AC and AD modulus, we don't need to worry about it because of the cos theta equal 0. Is cos theta equal 0, theta equal 90 because of the cos fundamental. Theta equal 90. That means AC perpendicular to BD. So now we have that adjacent sides are equal, and the diagonals are perpendicular to each other. Therefore, the quadrangle ABCD is a kite. Thank you. Please share the contents with your friends and other students, and subscribe the channel. Thank you.